Hi dear children, welcome to today's class. Today we are going to discuss tangents and normals. What is tangent? Tangent, that is a line which touches a curve exactly at one point. Exactly at one point. Okay. Tangent, that is a line which touches a curve at exactly one point. Exactly at one point, then we can say that that line is our tangent. A line which touches a curve exactly at one point, that is called a tangent. And normal, that is a line which is perpendicular to tangent. Normal is a line which is perpendicular to tangent. Okay. Now in this section we are going to discuss the equation of tangents and normal. Before going to that, we will discuss the slope of a line. Slope of a line. First one, let P of x1 comma y1 and Q of x2 comma y2 be any two points on a line. P of x1 comma y1 and Q of x2 comma y2 be any two points on a line. Then the slope of that line is given by, m is equal to y2 minus y1 divided by x2 minus x1. M is equal to y2 minus y1 divided by x2 minus x1. The slope of the line which passes through the point x1 comma y1 and x2 comma y2 is equal to y2 minus y1 divided by x2 minus x1. The second one, let ax plus by plus c is equal to 0 be the equation of the line. Let ax plus by plus c is equal to 0 be the equation of the line. Then its slope is given by, m is equal to minus a by b. M is equal to minus a by b. And what is this a? That is the coefficient of x divided by b, coefficient of y. M is equal to minus a by b is equal to minus of coefficient of x divided by coefficient of y. So the slope of the line which passes through the point x1 comma y1 and x2 comma y2, that is y2 minus y1 divided by x2 minus x1, and the slope of the line ax plus by plus c is equal to 0 is equal to minus of coefficient of x divided by coefficient of y. Now we are going to discuss the angle between two lines. The angle between two lines. So suppose we have two lines and let the slope of the first line be m1 and slope of the second line is equal to m2. We have two lines L1, L2. The slope of L1, that is m1. The slope of L2, that is m2. Okay. Now the angle between two lines having slopes m1 and m2 is given by tan theta is equal to plus or minus m1 minus m2 divided by 1 plus m1 m2. Plus or minus m1 minus m2 divided by 1 plus m1 m2. Okay, so the angle between two lines having slopes m1 and m2 is given by tan theta is equal to plus or minus m1 minus m2 divided by 1 plus m1 m2. Now, condition of parallelism and perpendicularity. Condition of parallelism and perpendicularity. Suppose we have two lines L1 and L2 and the slope of L1 is equal to M1 and the slope of L2 is equal to M2. Then how can we check whether the line L1 and L2 are perpendicular, L1 and L2 are parallel? If two lines are parallel, then the slope M1 and M2 they are equal. If two lines are parallel, then we will get M1 is equal to M2. Parallel. implies m1 is equal to m2, and perpendicular implies m1 into m2 is equal to minus 1. Perpendicular implies m1 into m2 is equal to minus 1. Or we can say that m2 is equal to negative reciprocal of m1. Or we can say that m2 is equal to negative reciprocal of m1. Suppose it is given that our two lines are parallel, that means the slope of the two lines are equal. Or if that two lines are perpendicular, then the slope of one is the negative reciprocal of the second one. The slope of first one or the second one, slope of one is the negative reciprocal of other one. Okay. Now, equation of tangent. Equation of tangent. Equation of tangent. The slope of the tangent to the curve, suppose we have one curve y is equal to f of x, and we are going to find out the equation of tangent to this curve. Equation of tangent to this curve. If you want to find out the equation of tangent to this curve, we need to find out the slope. Okay, we need to find out the slope of the tangent to this curve. Slope of the tangent to the curve y is equal to f of x, and the slope of the tangent to the curve y is equal to f of x is dy by dx. The slope that is equal to dy by dx. And if you are going to find out the slope at ordered pair x naught comma y naught, then that is equal to dy by dx at x naught comma y naught. Dy by dx at x naught comma y naught. Now, actually, we know the equation of a straight line passing through a given point. Equation of a straight line passing through a given point x naught comma y naught, having finite slope m. Having finite slope m is given by, this we already discussed in our 11th standard, equation of a line which passing through the point ordered pair x naught comma y naught having slope m is given by y minus y naught is equal to m into x minus x naught. Y minus y naught is equal to m into x minus x naught. This is the equation of a line which passing through the point x naught comma y naught with slope m. We are going to derive the equation of the tangent to the curve y is equal to f of x by using this equation. The slope here it is dy by dx at x naught comma y naught. If we are taking the point x naught comma y naught, then the slope at x naught comma y naught is dy by dx at x naught comma y naught. So what we want to do is we need to replace this m by dy by dx at x naught comma y naught, because here the value of m is equal to dy by dx at x naught comma y naught. So the equation of the tangent which passes through the point x naught comma y naught. Equation of the tangent which passes through the point x naught comma y naught is y minus y naught is equal to dy by dx at x naught comma y naught into x minus x naught. And I just replaced this m by dy by dx. Okay. Now, as I said, this normal means a line which is perpendicular to our tangent. Line which is perpendicular to our tangent, that is normal. Then the equation of the normal we need to find. Equation of the normal we need to find. For that, since this normal and tangent they are perpendicular, normal and tangent they are perpendicular. If two lines are perpendicular, then what is the relation between the slope? M2 is equal to negative reciprocal of M1. M2 is equal to negative reciprocal of M1. The second one, we can write it as the negative reciprocal of the first one. Since this tangent and normal perpendicular and the slope of this tangent is dy by dx at x0 comma y0. This is the slope of the tangent. Dy by dx at x0 comma y0. Then what will be the slope of our normal? Let it be m2 and that is equal to minus 1 divided by dy by dx at x0 comma y0. The slope of the normal is equal to minus 1 divided by dy by dx in at x0 comma y0. So we got the slope of our normal, and this normal is also passes through the point x0 comma y0. Normal is also passes through the point x0 comma y0. Therefore this equation is y minus y0 is equal to, just replace this by minus 1 by dy by dx at x0 comma y0. Minus 1 by dy by dx at x0 comma y0 into x minus x0. So this is the equation of normal. Equation of normal is equal to y minus y0 is equal to minus 1 by dy by dx at x0 comma y0 into x minus x0.